Okay, another example to just get more and more practice here. Expert witness in a paternity suit testifies that the length of pregnancy is a variable that's normally distributed. The normal amount of days in pregnancy is 270 with a standard deviation of 10 days. Okay, so here I'm talking about 20 pregnant women, not just one, but 20 pregnant women, and the average length of the pregnancies being in between this and this. Okay, so here I don't know. Well, here it says that it's normally distributed, which is nice. But even if it didn't say that it was normally distributed, the fact that we have 20 samples and the fact that we're talking about the average of that sample means that this distribution will be normally distributed by the central limit theorem. So I don't even need to know that the original distribution was normally distributed. It doesn't matter. Okay. So here then, the average of 20 women should be the average of the gestational period of the 20 women should be 270. Okay, that'll be the middle. So what's the probability that the average of 20 women should be between this value and this value? This will be normally distributed. So here's 270. Here's the lower limit. Here's the upper limit. This is the X bar scale. We're talking about the average of 20 women in this scale. We can convert these into Z values, of course. Here I'm talking about numeric data, not proportional data, not categorical data. So I'm going to use this formula. This is x bar minus mu divided by sigma divided by root n. So here then, this is 265, subtract 270, that's the middle, divided by the standard deviation, which is 10, and all over root n, giving me a z value of negative 2.24. Here I can convert this positive side then. This is 271, subtract 270, divided by sigma, divided by root n, and I get a z value of positive 0.45. Again, using my z table, I need to look up both of these values. Okay, so negative 2.2, and where it matches up with 0.4, and positive 0.4, and where it matches up with 0.05. I get these two areas. When I take the difference of these two areas, I find the probability of a gestational period for the average of 20 women to be in between these two values. There is a 66% chance that that happens. Okay. Also, you can use Minitab, either using the z-scores or the standard deviation of the distribution here. So here the standard deviation of the distribution, also called the standard error, is 10 divided by root 20, which apparently is 2.236. Okay, so here I am looking for the probability in between 265 and on the high side 271. I know that this distribution is going to be normally distributed because I am talking about the average of 20 people. Okay, so this is going to be normally distributed. I can use z-scores if I have 0 and 1. In this case, I'm going to use the x-bars. I'll say that the average really was 270, and the standard deviation, this is going to be sigma divided by root n. Okay, so this is 10 divided by root 20, which I calculated to be 2.236. Okay, the column that I'm taking the values from is the 19th column here. Okay, so here you can find the two cumulative areas from Minitab this way instead of from your Z table that way.